In today's video, we are going to talk about the characteristics of an oligopoly, and we're going to talk about game theory. Oligopolies is an industry dominated by a few large firms. These firms can either sell identical products such as steel or differentiated products such as cell phones. The reason there are only a few large firms is because of the significant barriers of entry. In order to determine whether or not an industry is an oligopoly, we use what is called the four firm concentration ratio. If the sales of the top four firms in an industry is greater than 50% of the total market structure, the industry is considered to be an oligopoly. The higher the ratio, the more concentrated the market. In an oligopoly, firms are considered to be interdependent of one another. Therefore, the largest concern for most of these companies is what will my competitor do? To help companies with the interdependence, we use game theory. And in game theory, we will use what is called a payoff matrix. In the example here, we have a 2x2 payoff matrix. The most important thing in a game theory problem is understanding how to set up the problem and how to read the payoff matrix. In our example here, we have Breadbasket as a company and Quick Lunch. We have two separate strategies, setting a high price and a low price. Inside each of the quadrants are what the payoffs are for both of these companies. To set up the payoff matrix, you will notice that the company Breadbasket, the company always on the side, will always be represented by the first value in each of the quadrants. As you could see here, I circled Breadbasket and then I circled each of the items, the first item in each of the quadrants. The second payoff is then for the company up on top, which in this case is Quick Lunch. I will put the arrows going vertically up and down for Breadbasket so that I'm able to understand how to read the payoff matrix for Breadbasket. For Quick Lunch, I will look horizontally at the values to understand the payoffs for Quick Lunch. One of the first things that you would have to answer in a problem like this is a company's best response. So in this example, if we had Quick Lunch deciding on a strategy of setting a high price, what is the best response for Breadbasket? So if Quick Lunch is deciding to set a high price, we will look at the two values in those two quadrants, and as we could see, the best response for Breadbasket would be to set a low price because the value of 120 is greater than 105. We could also look at if Breadbasket set a high price, what would be the best response for Quick Lunch? Once again, we will look horizontally and we will see that Quick Lunch should also set a low price. The next question you may have to answer is regarding dominant strategy. Does a company have a strategy that will work no matter what their competitor does? So let's look at Breadbasket to see if they have a dominant strategy. So if Quick Lunch decides to set a high price, what should Breadbasket do? So once again, we will look at the scenario and we will notice that, again, setting a low price would be the best response to that. If Quick Lunch sets a low price, what should Breadbasket do? Once again, Breadbasket should set a low price because of the $75 payoff versus the $40 payoff. When you have the arrows moving in the same direction, or in this case, breadbasket setting a low price, would be their dominant strategy. Another way this question could be asked is, does Quick Lunch have a dominant strategy? So if breadbasket sets a high price, what should Quick Lunch do? Quick Lunch should set a low price if breadbasket sets a high price. If breadbasket sets a low price, what should Quick Lunch do? They should set a high price. We will notice that those arrows are moving in opposite directions. Therefore, Quick Lunch does not have a dominant strategy. One of the major things that you will also need to determine is, do we have Nash equilibrium? Nash equilibrium is the concept of game theory where the optimal outcome of a game is one where no player has an incentive to deviate from their chosen strategy after considering an opponent's choice. Another way of looking at this, as I will explain, is each firm is stuck with that strategy. In order to be in Nash equilibrium, each firm needs to be stuck. If one firm is not stuck, meaning that they would use a different strategy, then that would not be Nash equilibrium. So let's look at the front left quadrant. In this case, the first question is breadbasket stuck? Well, no, they are not, because they would leave and take the low price because the 120 is larger than the 105. As soon as a company is not stuck, then you are not in Nash equilibrium. Let's move down. Is breadbasket stuck? Yes, they are, because 120 is greater than 105. They're not going to move. Secondly, we could then look at Quick Lunch. Is Quick Lunch stuck? Yes, they are, because 80 is greater than 70. So therefore, again, they are stuck. So when both firms are stuck, they are considered to be in Nash equilibrium. You can have more than one Nash equilibrium. So let's look at the top right-hand quadrant. Is breadbasket stuck? No, they are not. They would move from 40 to 75, so therefore they are not stuck. Let's look at the bottom right-hand quadrant. Is breadbasket stuck? Yes, they are, because 75 is greater than 40, so they are stuck. But let's look at Quick Lunch. Are they stuck? No, they are not, because 80 is greater than 70, therefore they would not be stuck. So, in this particular case, Nash equilibrium would occur where breadbasket has a low price and Quick Lunch has a high price. Let's use the 2015 AP question to see the different types of questions that would be asked in a game theory problem. So the first question reads, does each shop have a dominant strategy to set a high price, a dominant strategy to set a low price, or does it have no dominant strategy? So we will answer the question for both breadbasket and Quick Lunch. In this example, breadbasket has a dominant strategy of setting a low price, but Quick Lunch does not have a dominant strategy. You will notice that both arrows move in the same direction for breadbasket, illustrating the dominant strategy of the low price. The next part of the question reads, if the two shops do not cooperate on setting prices, what will be the profit for each shop? Essentially, what they are asking for is where Nash equilibrium exists. So in this particular case, Nash equilibrium does exist at the point where Breadbasket would have a profit of $120 and Quick Lunch would have the profit of $80. Once again, Nash equilibrium exists in that quadrant because in that quadrant, both companies are stuck. The last part of the question reads as follows. The town government is concerned that food prices are too high. It decides to give a daily subsidy of $20 to any shop that chooses to set a low price for its food items. Redraw the payoff matrix under the government subsidy systems. So when a company sets a low price, the following would happen. The 120 would now be 140. The 75 becomes 95. For Quick Lunch, the 130 becomes 150 and the 70 becomes 90. With the subsidy, would Quick Lunch choose to set a high price or a low price? Explain using specific values from your redrawn matrix. Quick Lunch will choose a low price strategy. The reason is that they will earn higher profits because the amount of $90 exceeds the $80 or profits increase by $10. Lastly, would the profits for Breadbasket increase, decrease, or stay the same? The answer is Breadbasket's profits would decrease from $120 to $95. I hope this video helped with game theory, and we will be giving you a lot of these problems in the future. Again, if you understand how to set up the payoff matrix and how to read the payoff matrix and what to look for, the problems become a lot easier. If you have any questions, please feel free to email me. I will also be having a Shobi chat both Tuesday and Thursday of this week at 10 a.m. Have a great day.